Hello students, in today's video I am going to teach how to solve a first order, first degree linear differential equations. First we learn about how to represent a linear differential equation or what is a general representation of linear differential equation and how to solve them. Okay. So we generally represent a linear differential equation as dy by dx plus p of x into y is equal to q of x. So this is a general representation of a linear first order first degree differential equation. Okay. So this linear differential equation is said to be linear in y. Okay. This is called linear in y because it is expressed as dy by dx. What do you mean by p of x here? P of x is nothing but it is a function of x. For example, you can have sin x or e power x or cos x, any function, any term which contains x or function of x. So p of x will be always function of x, and q of x on the right hand side, this term, this also represents function of q, which is function of x. So p and q are function of x. Okay. So any differential equation of this form dy by dx plus p of x into y multiplied by y is equal to q of x is called a linear in y. Then the next form of linear differential equation, it could be in this form, that is dx by dy plus p of y into x is equal to q of y. Okay. So this equation is called linear in y. Okay. Wherein you can see p will be function of y. Function of y. That means you can have sin y, cos y, e power y, 1 plus y square, root of 1 plus y square, any mathematical term which is function of y. And q is also function of y. Function of y. So such equation is said to be linear in y. So we can have two types of linear equation. One is linear differential equation which is linear in y, differential equation which is linear in x. So this equation, the second equation, this is linear in x. That means if the equation is represented as dx by dy, then we say the equation is linear in x. If it is expressed as dy by dx, then we say the differential equation is linear in y. So we have two types of linear differential equations now. One is in terms of dy by dx, other in terms of dx by dy. Now the thing is, if the differential equation is linear in y, then what is a method of finding the solution? How to solve it? So if the equation is linear in y, okay, first step is we'll find out the integrating factor. Okay, integrating factor. Integrating factor, or I can simply represent it as if. So if the equation is linear in y, then we write the integrating factor as e to the power of integral p dx. We know p is function of x. Okay, this will be the integrating factor. So for a differential equation, first we will find out the integrating factor, then the solution of the linear equation, the general solution of the linear differential equation. If the differential equation is linear in y, then the general solution becomes y into integrating factor is equal to integral of integrating factor into q dx plus a constant of integration. This is how we find the general solution of a linear differential equation which is linear in y. That means y into, what is the integrating factor? E to the power of integral p dx. Okay, this is equal to integral of, again integrating factor, e to the power of integral p ds into q of x dx plus c. Okay, this gives the general solution of a linear differential equation which is linear in y. Okay, now we will see if the differential equation is linear in x. Okay, if the differential equation is linear in x, that is of the form dx by dy plus p of y into x is equal to q of y, then what will be the integrating factor and what will be the general solution? Okay, so if it is linear in x, then the integrating factor becomes e to the power of integral p dy. Okay, because why we write integral p dy? Because it is linear in x, p will be function of y. Therefore, the integrating factor becomes integral p dy, because p is function of y. That means you have to integrate with respect to y. This is the integrating factor. And general solution becomes x into integrating factor is equal to integral of integrating factor into q dy plus c. Why x into integrating factor comes? Because if the equation is linear in x means you are solving it for x. What is x you are finding out, right? Therefore, the general solution will be x into integrating factor is equal to integral of integrating factor into q, integrate this with respect to y plus the constant of integration. That means x into integrating factor is e to the power of integral p dy, okay, is equal to integral of e to the power of integral p dy, okay, into q, which is function of y, dy plus a constant of integration. This is the formula if the differential equation is linear in x. Okay, have you followed? So, keeping these two formulae in mind, now we will solve some problems based on the linear differential equation which is linear in y or linear in x. Okay, so take a look at one problem, a simple problem. I will explain you. Now the problem is like this: solve dy by dx plus y secant x is equal to tan x. Okay, so looking at this differential equation, you can easily judge the equation is linear in y. Let me compare this with the general form: dy by dx plus p of x into y is equal to q of x. This is a general form. So compare this. The equation is linear in y. You can write the value of p of x just by comparing. What is the value of q of x if you compare? So p of x will be secant x. Okay. So what is q of x? Q of x will be tan x. Okay. So now I will find out the integrating factor. It is integral of p dx, right? Just now I have explained you. So therefore, e to the power of integral of secant x with respect to x you are integrating. So what is the integration of secant x? It is log secant x plus tan x. Okay. Now log base e will be there. What is the value of this? This becomes 1. E to the power of log base e value is always equal to 1. So I will get only secant x plus tan x. Therefore, the integrating factor becomes secant x plus tan x. Now I will write down what is the general solution. General solution will be y into integrating factor. What is the integrating factor? Secant x plus tan x. This is equal to integral of, again integrating factor, that is secant x plus tan x, okay, into q of x. What is the value of q of x? It is tan x dx plus the constant of integration. This is a general solution for this differential equation. Now I will integrate the right hand side value. So I'll multiply this with tan x. Okay, secant x into tan x, integral of secant x into tan x dx plus integral of tan square x dx plus a constant of integration. So what is the integration of secant x tan x? And what is the integration of tan square x? Integration of secant x tan x is secant x. Okay. Now to integrate tan square x, what I will write? I can write tan square as secant square x minus 1. Okay, correct? Using the trigonometric relation. Now secant x as it is, integration of secant square x is tan x. Integration of 1 with respect to x is x plus a constant of integration. Take a look at this. Integration of secant square x is tan x. Integration of 1 with respect to x is x, dx is x plus a constant of integration. So this will be the general solution of the given differential equation. Okay, have you followed this? Okay, I'll repeat this. I have replaced tan square x as secant square x minus 1.